Hello, this is Dennis, and in this video, we're going to run through the Excel work necessary for the CO2 project. And the first thing I'm going to do is share my screen. And the next thing I'm going to do is I'm going to go to D2L, which is already there. I've got D2L up for one of the classes. And I'm going to go to Content. And when this finally comes up, under Class Project, I'm going to click on that. And now I'm going to click on this first one here that says College Algebra Project. This is our write-up. And this is a PDF file. It displays in the right-hand half or the right-hand two-thirds of the screen here. And I'm going to go down to the point where we have this link right here. This is the link to the site where we're going to get our CO2 data. So if I just click here, it will open up that link in another tab. And notice the title. This is Mauna Loa Observatory in Hawaii. And it's a subsidiary of Scripps Institute of Oceanography. This is the Scripps CO2 program website. And if we go down here under Flask CO2 data, there is two files under there. There's a daily Flask, 1960 to present, and a monthly Flask, 1960 to present. We're going to download the monthly Flask, and all you need to do is just click on this and it will download to your download file or download folder. And I'm going to go to the file now in the folder and click on it. And it came up in another window. How about that? So I'm going to have to fix the screen sharing from here on. So I'm going to have to go back to unshare and then share again. Share Excel here. So what's coming up is this is the screen, the Excel screen. Actually, there was a little window that came up with this when I opened it that asked if you wanted to convert this file or leave it in the current format. The format was a comma separated variable. It ended in .csv, and I hit the convert button. Oh, we recording or not? Okay. Anyway, sorry for the pause there. Um, at the top is a bunch of header information. And if we scroll down to about line 53, 54, this is where the actual data begins. It's in several columns. And notice that it starts out with the year 1960, month 1 through 12, and then 1961, month through 12, etc. And then there's a column called the date in Excel format, and then the date in another format, CO2 seasonally adjusted. PPM stands for parts per million in these columns. And then one called FIT PPM, and this is the carbon dioxide, atmospheric carbon dioxide concentration data we're going to be using. But we're not going to start until we get to 2004. So I'm going to scroll down 1964, 1970, 1993, 96, 98, 2001, 2004, month one. And what I'm going to do is I'm going to click on the first year where it says 2004, and I'm going to drag down what we're doing is we're selecting this column and go up to month 12 of 2024. And now I'm going to go across to grab the rest of the table, let up on the mouse button so this remains highlighted. If I hit the right cursor now, it allows me to copy. So I've now copied all of that content, and notice it puts a little green dashed line around what I've just copied. And I'm going to put this into a new tab. So if you go down here at the bottom where it says monthly flask CO2 MLO, yours may say something other than 4, there's a plus next to it. If I hit the plus, it'll open up a brand new sheet. And I'm going to go up to somewhere around, say, B4. I'm going to select that cell just by clicking on it. Notice it highlights it with a solid green box. And now if I hit the right mouse button and copy, hit the right mouse button and copy, what the heck happened here? Oh, I got to go back and reselect it, I guess. This time let me hit Control C to copy it. And then go back to the sheet and hit Control V to paste it. There we go. So this just pares down that data until we get the data we're going to work with. And in fact, a lot of this we're not going to use. What we're going to use for the date is column E. So I'm going to go to the first blank column above where I just copied or pasted that data. And I'm going to write down date, D-A-T-E. Then I'm going to go over under column G. This is the column called fit ppm on the other one. I'm just going to call it CO2 space parentheses ppm close parenthesis. And those are the two that we're going to actually use. I think, well, do I have the right one there or not? No, I do not. Sorry, correction. Take this, delete it, and put it over the column that starts with 376.92. Space ppm close parenthesis. So the ppm stands for parts per million. The CO2 stands, of course, for carbon dioxide. And now we're going to get rid of some of this data that we don't need. We don't need anything that's in columns F or G, or at least the way I pasted it, it doesn't. Yours may look a little different depending upon where you pasted it. But we want to get rid of columns F and G. We're not going to use those. So I'm going to go up here and click the left mouse button. That'll select the entire column F. Now I'm going to drag it to the right and select G as well. Let up on that button. And now if I just hit the delete button on the computer, that all goes away. Actually, what I wanted was the delete here, which will not only take care of the data, but will actually fill those two columns in with sliding the data from the right. These last two columns we don't need either, so I'm going to select H and I. Actually, I'm going to select G, H, and I from all the way up top. I'm going to hit the right mouse button and then hit delete, and those three columns will now be cleared out. Now we're going to make our first chart, and it's going to start with selecting everything in column E and F, including these headers where it says date and CO2 in ppm. So I'm going to click on where it says date. I'm going to drag the mouse down. Also going to go over and get the other column. And now at the bottom of this, I let up on the mouse button. I've now got those two columns selected. That'll be the information we're going to put into a chart. To get at the chart, we push the insert up here at the top. Click. And what comes up is all kinds of things that we can insert. We're interested in this stuff right here called charts. And in particular, if we go away, if we stop it. Come on, go away. We click on this one and select this one, the first row, third one over. It's going to make a nice little graph for us out of that data. Just let up on the mouse button and it leaves the graph there. It took the title, CO2 and ppm. The vertical column are the CO2 concentrations out of column F. The horizontal down here are the year, and it gave us year from 2000 to 2030. And also this graph kind of overlays the data. I'd like to move it. So it's selected whenever you've got these 4 circles around the border. Actually, there's 8 circles around the border. If you just click inside of that and drag your mouse, you can move this graph. So we'll move it over here and get it out of the way. And let's make it a little bigger so we can also work with it. So if we grab one of these corners, like say this lower right-hand corner, click, and now you can stretch the graph. And it's best to stretch it from a corner because that will scale both the vertical and the horizontal. If you stretch it separately from the top or the side, it'll distort the graph. And I made that just a little bit big. So let's make it a little bit smaller. There. It took these little icons away. So in the plus icon, if you hit plus, up will pop another sub-menu called Chart Elements. We want to go down to where it says Trend Line, but don't click on it. There's a right pointing arrow. Click on that, and it brings up a sub-menu. And under that sub-menu, we want to take the mouse, move it over to More Options, and click on that. And finally, it'll bring up a menu called Format Trendline. And it'll give you a bunch of different options for what type of a function do you want to try to use to fit this. For this data, we're going to use an exponential, so click on that first choice right there. And then scroll down to the bottom. And there's another box called Display Equation on Chart. Click on that. And then the one below it, Display R² Value on Chart. Click on that. And now you can close this window by hitting the little X up here. So it has given us an approximation. It gives the equation right here and some information. This information R² is about how good a fit the equation is to the actual data. And it gives us a little dotted line running through the data, which is a plot of the equation that it gave us for fit. Now, I don't like where this information is sitting, the equation and the R² value. So I'm going to hover my mouse over it and click, hold my left mouse button, and I can move that. So I'm going to move it over, say, here somewhere. And I also don't like that it's so small that I can barely read, especially this exponent up here. So I'm going to select everything in that box, let up on the mouse button, and up will pop a window where I can edit the font. And I want to edit the font size. I want to go from 9 up to maybe 12. Okay. And then I can click and it gives me something that I can more easily read. So this equation, y equals 0.0033 e to the 0.005, I think that says 8x. That's the equation for the line, that's dotted line that's running through the data. That is what's called the trend line equation. And an R² of 0.9729 is a pretty good fit. If you have an R² that's equal to 1, that's a perfect fit. And the lower the number, the worse the fit is. 0.9729 is not too bad. So we'll keep it with that. Okay, another chart you're going to want to make uses the same data, except we're only going to do 1 year's worth. So for that, go to 2024 month 1, and then go over to these last 2 columns and click there, and then select those last 12 out of those columns. What we're doing is we're going to set up to plot a 1 year's worth of data, just so you get to look at one cycle of those wiggles that the other chart is doing and move in on it and get a better look at it. So when I have those selected, I actually want to make another copy of that. So I'm going to hit Control C to copy it. And now I'm going to go down here a little bit. I'm going to do Control V, and it will paste that data. So I've got another copy of it. The reason I made a copy is because I want to take these 2024 dot and then 3 more digits, and I want to change those to the month of the year. Month 1 is January, so I'm going to type JAN, enter, and then FEB, enter, MAR, enter, APR for April, MAY for May, whoops, MAY for May, JUN for June, JUL for July, AUG for August, SEP for September, OCT for October, NOV for November, and DEC for December. And then above that column, in this empty cell above that, I'm going to click on it, and I'm going to type month, MONTH. And then in the next column, I'm going to type CO2, CO2, and open parentheses, ppm in units of parts per million. And now I'm going to select this little table, including the headers, and we're going to make another chart out of those. So we go back to Insert, and this time we want this set of charts right here called Insert Line or Area Chart. So if we click there and pull down to say this first one, a line chart, that might be the best we can do. Let's see. Yeah, let's go over and pick this one, line with markers. Just click on that. And there is 1 year's worth of the variation in CO2, starting in January and ending in December. And this is for the year 2024. That's the year that we copied. We're not going to do a trend line for this. Oh, by the way, we're going to move this because it kind of put it in a bad spot. And we're going to make it a little bit bigger so it's easier to see. And on this one, I'm going to show you how to scale the axes. Notice all the unused space below this, like from 419 to 422 parts per million. We're going to scale that so that the minimum is 422, and that'll give us a bigger chart. It'll make more use of the chart area. So we go to the plus, under axes, go to the arrow pointing right, click on that, and we are interested in more options. So under that, under this format axis, up top here, there's a selection called axis options. Click on that, and then pull down to vertical value. Click on that, and we get some boxes we can play with. The first box gives us a minimum value on the axis of 419. If we just click in there, delete that and type 422, not 420, yeah, 422, and 0.0 just to be consistent. And now we just close this. It rescaled that vertical axis for us, and now we're using more of the chart. So it's a little easier to see what's going on. So this is a 1-year cycle, sometimes called a sinusoid. It's a bunch of straight lines between the dots. The curve is actually supposed to be smooth, but since we're using just monthly average data, our data looks a little coarse. If we had done this with the daily data, we would have gotten a nice smooth curve. One thing to point out though is if you look at where 2024 started at just a little over 423 ppm and ended at about 425 and a half, almost a half, that is the amount of CO2 the atmosphere gained in that year. But overall, it went to a maximum in May of, if I put my cursor on it, it'll actually give me the data, 427.36 for a maximum, and a minimum in September of 422.11. Okay, so one of the questions you're supposed to answer in the project is, what is happening that causes this variation in CO2? when the man who started taking this data, Charles Keeling, saw this back in the late 1950s, early 60s, when he saw this repeating pattern after the first few years, he actually made the comment that he has seen the Earth breathe, taking one breath per year. What is the Earth doing during these months that is responsible for this rise and this fall of, and then back to another rise of CO2 as you go from January to May to September back to December. So that's where we'll leave that one. You're supposed to make one more graph, and for this one, we're going to make the data ourselves. So if we just go down here any place and click on a cell, we'll put a header here, CO2 parentheses ppm. And then in the next column over, we're going to put something in here like, say, TEMP space RISE for temp rise. And then in this next column, let's call this sensitivity, SENSTIVITY. And let's, well, under CO2, the first data we're going to enter, we select this cell and just type 280. The next cell down, we want to double that. So here's where we're going to show you how to enter an actual formula. We have this cell selected, so if we type enter, or I'm sorry, equals, the equals appears there. Also notice that the equals appears up here in what's called the equation bar. So whatever we're typing down here appears up in the equation bar. And what we would like to type in there is equals 2. And then on Excel, the multiplier is the asterisk. So I'm going to type asterisk. And now I'm going to click on the cell above it. Click. And it puts the address of that cell. And in this case, it just happened to be D277. And now if I hit enter, it replaces that formula with 2 times the contents of the cell above it. 280, you double it, you get 560. If I go back and click in that cell, the 560 will stay there, but look up here in the equation bar, it shows you that there's an actual equation applying to that formula, or applying to that cell. And now we would like to double this a couple more times, so let's grab or select that cell where that 560 is at, and push Control C to copy it. And notice it highlights it and gives you green dashed lines around it. And we would like to copy that in the 2 cells below. So I'm going to select the cell right below it and hold my left mouse down, drag it down 1 and let up. So now I have selected those 2 cells below the one that I have copied. If I hit Control V, it will copy the formula from above. And remember, the formula that I put into this cell was multiply the contents of the cell above it by 2, which is what it did. If you go down this one cell below it, it's another 2 times, but now it's the cell right above it, the one with 560 in it. So when I copied down the formula, Excel automatically incremented the cell number so that each cell in this little column of 4 is multiplying the contents of the column above it by 2. Now, temperature rise, well, let's go over to sensitivity. And for right now, we're just going to type a 3 in the box under that header that says sensitivity. And now for temperature rise in this first one, let's click here and then type equals, and then go over here and click the cell next to it. And it establishes the formula equal F277, which is the contents of the cell next to it. And now we hit enter. So it copied the 3 over. There's a formula there. And now for this cell below it, what we would like to do is take the contents of the cell above it and add the contents of this cell underneath the sensitivity. So on this cell, we click there, we're going to type equals, and now I'm going to go click the cell above it. And now I'm going to hit the plus for add. Excuse me. And now I'm going to go over and click the cell to the right of it under sensitivity. So notice it says equals E277 plus F277. And I'm going to also copy this formula into the two cells below it. And I would like to lock this cell F277 so that Excel doesn't increment it. Oh, sorry. So I'm going to put $1 in front of the F. So click in front of the F and put $1. Curse over, and in front of the 277, put another $1. Whoops, $1 sign. So that will lock that cell so that when we copy it, this cell, and paste it into other cells, this F277 will not change. So now I hit enter, and notice that this cell is equal to this cell plus this cell. Now let's copy the formula in this cell where the 6 currently is. So Control copy, and now we're going to paste it below in these two cells. So select, drag down, get both of those cells selected, hit Control V, and notice it populates them with a 9 and a 12. So if we go to that cell with a 9, notice that it kept the F277, but it did increment to the cell 278, which is the one right below where the 3 is, the cell where the 6 is at. If we go to the 12, it incremented the cell to 278, but it kept the cell F277. So that's what the dollar does in Excel. It tells Excel to lock this cell when you copy formulas. Okay. The reason for doing that is because we're going to change sensitivities and do some analysis based on different sensitivities. So if I had to go to this sensitivity number and click on it and say type a 2, enter, watch the information underneath the temperature rise, it all changes. So the first one is 2, and then 4, and then 6, and then 8. Each one of these cells is incremented by 2. If I went to that sensitivity number and I type 4, enter, now the temperature rise numbers go to 4, 8, 12, and 16. So we set this up by the way we entered the formulas into this table. The last thing we're going to do here as far as charts go is we're going to select the CO2 and ppm and the temperature rise data. And we're going to do insert of a chart. So insert over here under chart, not that one. Oh, I'm fighting the banner again. Insert this one. Escape. Insert chart. There we go. And let's insert this one right here. So that gives us a curve with a little bit of a different look. We are going to attach a trend line to this one. So let's go up to this plus sign, which will be there anytime the chart is selected. By the way, if you select any cell that's out of the chart, these 3 icons go away. If you ever want to get them back, just put your cursor inside the chart and click, and those icons come back. So again, under plus, the next menu, go under trend line, hit the right arrow. Under that sub menu, go to more options and click. And now this time, select the logarithmic. You're going to see the logarithmic and the exponential when we get into chapter 6. But right now, we're selecting a logarithmic function as our best fit. And if we curse down in this trend line menu, hit the display equation and the display R squared on chart. And then you can close this. And here's your equation. I'm going to move this to someplace more convenient. I'm also going to make it bigger. So I'm going to select all the text and I'm going to change it to 12-point font. And then I'm also going to move this chart because it's covering up that sensitivity number. It's also too close to the chart above it, so let me pull it down a little bit. And let's make it bigger by grabbing a corner and stretching it. Okay, there we go. So there is the stuff for this chart. And the purpose of this chart is to give you an approximation for how much temperature rise can be expected versus what the CO2 content is. So notice if I go back to this 4 in under sensitivity again and select it and hit 2, watch the data under the temperature rise column is going to change, but watch what happens to the charts. The chart adjusted and also the trend line changed. So it automatically updated when you updated the sensitivity number. So this part of this spreadsheet is all locked to that sensitivity number. So you can type anything in there you want. And now this temperature rise chart, I think we want some more granularity, especially for the vertical. So let me select the chart, go over to the plus, and under axes, hit this. And let's see, I think it's primary vertical, more options, bounds, units, auto, okay. Axes options, let's see. Okay, horizontal grid lines. I want vertical grid lines. Grid lines, there we go for vertical. Ah, all I did was turn them on. Well, I'm not finding what I'm looking for here. Let me start over again. Plus, grid lines. Let's try more options. No, that's not what I wanted either. Plus, grid lines. I think this just turns them on and off. Yep. Minor. Okay, it didn't help. I'm not finding what I'm looking for. So let's just leave it right here. I'm going to close out. And if I figure out how to do this, I will tell you about it during class. So good luck with it. And I'm going to turn off the recording.